I'm talking today about digitalization of the vivarium, past and present, and just to show you what we'll be going through today, here's the overview. We have different animal room monitoring systems and then rack and blower units, and I'll be spending a lot of time on cages. That's been my passion for many years and still is, and I think it's an interesting time for the lab animal community in regards to opportunities of how things are progressing technically in that area at this current point in time. And then we need to talk a little bit about infrastructure needs and then operational efficiencies and potential returns on investments in relationship to what we are talking about, and relative unapparent communal efficiencies and benefits, meaning working with the PIs and some of the ways that some of these caging systems can help in other areas of the vivarium rather than just the animals alone. So I'll do a summary and questions at the end as well. So to start off, what I'd like to do is talk about some established and well-known systems, such as the Siemens BAS integrated system, or Apogee, and then go into Edstrom Watchdog, and then Air Acuity. And these were picked because these are ones that I've worked with in the past and know fairly well, but it also is an evolutionary type of approach here in regards to our digitalization and how they're working within the building automated systems. And it's also a way of showing the technology involved with this overall. These are fully interactive with the BAS. The initial focus was always on animal welfare components, the alarming and ability to notify. These are still very crucial components throughout all these systems. And then there have been improved interactive abilities and remote capabilities as we've gone on. Air conditioning and control tends to be one of our huge resource consumptions for the animal facilities, and one where we have a lot of cost in regards overall to this. It represents a major ROI for institutions with rapid short-term returns if it can be managed appropriately. So, excuse me, just showing some of the examples here of an Apogee system, and that's kind of a building-based system with that. Excuse me again. And then Siemens, within their units, have developed onto the Italian system, which is more of a common university multi-building type system to go ahead and manage these and then look at airflows and needs with that. In essence, we're starting to look at more smart building type of situations here with many different sensors and ability to go ahead and control the flows on more of a need basis, especially with some of the ducting systems in relationship to our airflows for hoods and other areas within the biological confinement or containment facilities overall. When we start looking at the Edstrom system, and that was predominantly based on more of a security basis and looking at room control and ability to enter the rooms and then go ahead and monitor who's in the rooms, as well as frequency of going into the room, security of the room itself, and then adding in the water flow concerns and abilities to monitor that and to keep those systems monitored and digitalized as well. There is more evolution with this. They're working to integrate more into other systems with this system, but essentially it's a standalone system at this point in time for them. But I think they are moving toward working more in other relationships with this at this area of time. This is still a very good system. It allows leak control and other issues to be monitored overall. Those are important concerns for us. We're starting to look at more air quality issues, and really when we start looking at that, air acuity comes into play, and the air qualities that we're looking at are based on 3 or 4 different bases, or 3 or 4 different areas that we're looking at. CO2, temperature, humidity, of course, which has always been one of the issues, but also TVOCs and being able to monitor the VOCs overall, and being able to go ahead and accommodate airflows in relationship to that. What I've noticed a lot in a lot of the primate facilities that I've consulted or worked with is where they are actually able to look at particulate, and particulate is a big issue for us, and then monitoring or ramping up when there are high particulate times and decreasing airflows when there's decreased particulate times. This is essentially tied into washdowns and ability to monitor around those and be able to monitor the airflows around those and anticipate some of those ahead of time. So ramping up just before washdowns and then waiting until those particulate matter drop enough and then coming back down to where it is within control. Also, with different stocking densities, you will get different CO2 levels. They are very good at monitoring that and looking at the airflow needs through that and everything that is related with that. As I mentioned, air quality is becoming more of a challenge across all of the world globally. We still have designated flows in Canada and England. They're on engineering standards still, but I'm understanding that that may move in the near future here, especially with Canada to start and England possibly to follow. Holding rooms are at about 6 to 10. The average is 8 in terms of room or air exchanges per hour. And this is based on the rack exhaust rate and thermal loads. Labs tend to be at about 2 to 4, the average of 3 exchanges per hour. Air quality, TVOCs, ammonia, CO2, and particulates are the 4 areas that are really heavily monitored here. And demand-controlled ventilation is then allowed. The monitoring is about every 15 minutes with established parameters. And your response times, you need to be able to respond to changes in that, but you don't want to respond too rapidly because otherwise you'll never have a baseline. So usually there's a 5 to 10 minute baseline response time and then reconfiguration before it is responding to in that sense with that. So this kind of gets us on to the BAS itself and development. And really what we're seeing now is with smart buildings, there's 3 emerging technology trends in building automation. And cloud computing is one of them, machine learning and artificial intelligence, and then connectivity and integration, or the Internet of Things. And that's really what we're starting to talk about with some of the airflows and some of the different particulate matter sensing, CO2 sensing that we're seeing in some of the space areas for the lab animals. So this is building into a concept, the Internet of Things, that is coming very rapidly into our areas of technology. And we need to understand this and hopefully help with this overall. As another example, I wanted to go into the rack blower unit digitalization. In the circa of 1990 IVCs, with their introduction then, there was a lab animal welfare emphasis in airflow predominantly and the alarm and notification focus with these blower units. The room versus individual rack. Individual rack, the assurance of backup power to supply units as well was another critical component for the animal welfare. And with these, we also saw a little better ventilation control per rack on these than in the rooms overall. Rooms were very hard to control with everything with that. So with individual IVCs, the racks tend to be the primary control basis for HVACs. And then what we're seeing is where we can either duct out into the primary system or use these individual blower units and use them to ventilate the cage that way. So CIRA about 2014, temperature and humidity monitoring emphasis on individual racks and remote monitoring. That was something that there were humidity additions available. They needed water supply to the units. So that was important as well in terms of any of the design function for facilities. And circa about 2016 here, we started to see individual health monitoring at the rack level. This is not digital, but it's manual. And this is something that could be digitalized in the future, possibly. We'll talk about that in a little bit. I wanted to just show some pictures of different rack and blower unit digitalizations here. So again, going into main lines this way for the building facility systems and pulling the exhaust air out with that, or going ahead and bringing the exhaust air into the room via some of the blower units. So there are many different configurations of this and ways to do this. The better ways in some of these situations based on noise and vibration is tending to look at standalone blower units and wondering or working with that, or working with the building system itself where you can hook into that. So these are things that we need to think about when we're designing facilities and when we're working toward developing the best rack system and air quality to the animals with that. The lower unit digitalizations, you can see here that we have the Wi-Fi unit setups, and these again are very popular and have the ability to individually set different flow rates for different racks and alarms for different racks, and the ability to correct those remotely as well in relationship to the digitalization of these and the ability to use Wi-Fi components with this overall. With the humidity and temperature, again, these are getting more advanced as we progress. And in the Nordic areas, areas of high altitude, these are very critical and important. A lot of times our building systems can't keep up with the need for the rack in regards to individual cages especially. So these systems are becoming more popular, and you're starting to see these more prevalent throughout the community. These can be either locally or centrally controlled, and looking at remote now with some of these as well in relationship to the digitalization, again, with the focus on animal welfare with this. The other area that I mentioned earlier was the health monitoring on the racks. So we're seeing a lot of the EAD now being used, or the exhaust air dust. These systems are built into the plenums and then have filters that are detecting what is going on with that exhaust air dust, or collecting that exhaust air dust is what I should properly say here. And there isn't technology at this point in time where it can automatically say that there are problems or anything along those lines. But there is other technology out there that is being looked at by several folks and several companies to evaluate the possibilities of having automated systems for this in the future. So this is something else that is exciting and possibly coming down the line in the future in relationship to this. We're seeing some of this also with the possibility of looking at this in regards to the zebra fish tank setups as well, and monitoring them and looking at automation of that in regards to some of the results we might get from that. So what I really want to spend time on is cage digitalization. And when we start talking about cage digitalization, I'm really talking about automated home cage monitoring and technology evolution here. Really, if we want to say what is the first way that we monitor cages or animals continuously 24/7, I think we would have to agree that telemetry was the basis of that, and starting early beginnings, where we could go ahead and monitor the physiological aspects of an animal 24/7 via telemetry, and still do in many cases. What we did see is with this early evolution, there were problems with battery systems, implanting these and others, and this has evolved now to where some of these units are battery-less. They work off charging systems underneath the cages themselves, and can be implanted in animals that way. So there's been quite a lot of digitalization for the animals and for the caging in regards to that. And some of that is EMF-based related to those charging systems. There's better and more advanced progress with behavioral studies, and then doing video analytics. And this was a neuroscience drive with this, with some of the behavioral components, and then developing algorithm programs based off of the video diagnosis, and looking at what type of behavioral aspects are occurring with these animals with that. This is primarily study focused, and what we were seeing is then with this, the ability for some of the algorithms to be quite sophisticated and be able to tell us what type of specific type of behaviors the animals are having. Most recently, we started seeing the electronic magnetic fields, the low electronic magnetic field development and usage for management and study use. The advantage of EMF or LEMF is that it allows both management of the cage and study evaluations as well. So it has a kind of a dual focus that way, and I'm going to spend a fair amount of time talking about the EMF abilities with the technology and how that works, and also comparing that to some of the other video systems and other ways of doing behavioral analysis with that. Animal welfare focus predominantly with these automated home cage systems. The continuous nature of those allows 24/7 evaluation for animal movements and then also in some cases a cage environment. Emphasis on better study conductance, continuous study data in the home cage so you're not having to move animals out, disrupting those animals and causing complications in regards to the stress that the animals might have or the non-acclimation of this different study apparati that they might be moved into. And more recently, we've been seeing EMF cage management with this in terms of the ability to actually determine when cage changes or cage change-out cycles should be determined. So we'll evaluate that and look at that as well here in this presentation. There's opportunities in all of this for great resource savings, labor and consumables, as well as the ability to have better reproducibility of data on data sharing overall. Some of the home cage monitoring systems are mentioned here, and looking at the technology, we can see that a lot of it is video-based and RFID chips, so you can individually identify animals in that. But also there are beam brake and vibration systems. There is also some gas monitoring for metabolic needs that way too with some of these systems. And the very last one down there with the technology is EMF. And again, I'll get into that more, but this is a caging system that, or a technology that's fairly new in regards to being used in this manner. And it's been Eurocentric predominantly, but it's really coming over to North America now. We're seeing this more and more now here in North America. So what do these look like? Here are some of the cages. There are some with the video RFIDs, as you can see in the upper left-hand corner there. The beam brake vibration is kind of in the middle there. Another video or non-RFID, but just video system here is on the upper right. And if we look at some of the metabolic cages here, like this one in the lower left-hand corner, you can see here that really there's some changes in regards to the actual holding cage from what you would expect for being a normal cage. The one thing about the EMF system is this allows a normal cage being placed into its holding environment, and then the environment measures the activity and measures the animal, much the same as these video systems are doing here and here, where the home cages are the home cage itself, what we would describe as a home cage, but we're not altering the tops, nor are we altering the cage itself and then letting the animal live in there and acclimate for 3 or 4 weeks. They are the cage. It's already acclimated, and this is a great time savings in the facilities in regards to acclimation periods and stabilization periods for the animals overall. So I just wanted to clear that up and make sure people had a good understanding of that, because there is a lot of variety in what is defined as a home cage system at this point in time. The cage digitalization itself, if we're looking at that, you can actually monitor animals for behavior and welfare components. And then the environment and welfare management, again, with some of the caging systems, like using the EMF systems for that. It allows cage inventory management and resource allocations as well. Adds to and enhances automation support of the Internet of Things overall when we're working with those. So really, for 50 plus years, the mouse cage has been a box, and we haven't done a lot with that box. What if you could provide information to the user, like the bedding condition, cage change scheduling, animal activity or lack of activity? And what if the cages were really based on need criteria rather than calendar? And I think this is an important concept here. We're really starting to see more and more of this in vivariums now, where people are looking at criteria rather than calendar. For years, we've used calendars, and there's been huge waste in regards to the calendar-based systems and the ability to manage those systems well in regards to the resources. So what is considered a dirty cage is a dirty cage reproducible in regards to different facilities. And again, each facility will have its own definition. The ability to go ahead and say what a dirty cage is something that, the system should be able to do. Can we reduce the risk of the animal allergy exposures? And how can we reduce that risk overall? By lack of changing cages too often, or having animals exposed too often overall from moving the animals from one cage to another or into study experimental areas with that. A researcher doesn't have to worry that his or her mice are being stressed by cage changes and could collect data in a home cage would be something that would be very optimal as well. Research and management can accurately tell when each cage change occurred to enhance study management and study correlations overall. So this is important, I think, too, for everyone involved. Intercage monitoring, the bedding conditioning modules could increase efficiency by changing washing based on need. And we'll get into a specific study that I'll show you that and what that actually means in terms of a decreased amount of cage changing. And combining intercage monitoring with complete cage change combines benefits overall. Same technology that monitors the bedding can collect other data. The systems are quite varied that way. We can look at activity, presence of food, water. And this is being shown here in regards to how some of the food and water can be evaluated in these systems with the infrared beam technology, and then indications when those are issues of a alert overall with a red light indicator. The other thing I'd like to point out is that not only does it measure that if there's a water bottle presence, but the actual correct positioning of a water bottle, not put in upside down, and the level of water within the water bottle as well. These are all management concerns that we've had in many different facilities, and this is something that can give great relief when you're having a system that will allow some of that to be measured. So some of the questions that may come from our facility managers: did I remember to put that water bottle back on, what I just explained? Are we going to have time to prepare for ALAC? Is there absolutely no way I'm going to have enough time today to do census? So what am I going to do if Brian called out sick? These cages really need to be changed today. Is work distributed evenly throughout the staff? Did Bob really change all those cages today? When is this mouse going to have her pups? Great question. Where is Dr. Winter's cage of important mice? We've never had that question, right, from anybody. Are we wasting food or bedding? And how much food bedding do I need to order? How many cages do I have right now? How long has this mouse been dead? Is this mouse acting crazy, or is it me? Am I going to have to justify more staffing? Or how can I justify even more staffing? And is this guy ever going to stop asking questions? So I hope I didn't cause any anxiety in folks with all of these mentioned questions here. But again, these are common questions. And a lot of the things that we do within the facilities can be answered through some of the technologies that we have available to us. One of the things that we need to start thinking about is how to let it go in terms of worrying too much. And there's a great book out there called Getting Things Done, The Art of Stress-Free Productivity. I would recommend it as a read to all who are listening. And a lot of times what we want to do is, we kind of register problems in our minds, and we always think about those problems, but we know it's not a big problem, but, we're not going to go ahead and spend all our time on it, but we actually do. We kind of keep coming back to that and everything that way. So if there's one thing we can do, the happiest people are those who can do it with the limit of their ability, and we can be completely present. We can be all there. We just need to let it go, and we need to give all our attention to the opportunity before us, not worry about those other little things that can be handled other ways, and we really need to focus on letting it go. And we can rely on technology. One of the things that our community is not real good at is going ahead and moving forward with technology in a rapid fashion or in an acceptable fashion in a lot of ways. So really, the advantages of the technology is the security, the consistency, the efficiency, and then the options that it allows us to go ahead and really pick through in ways that we want to manage and we can best manage with what resources we have. So having that in mind, there's some ways that we can go ahead and look at cage digitalization. And looking at the real thing here is the concept of the Internet of Things. I don't know how many folks have heard of this term before, but it's really coming on, and it's really the interconnectivity of processes and ability to plan and allocate resources efficiently and effectively. And there's a lot of interplay here then with smart technology in relationship to this in the Internet of Things, and being able to do a lot of analytics and being able to interplay with those analytics and look at the best path forward in a lot of conditions. With the introduction of the Internet of Animals, I wanted to talk a little bit about a paper that had come out in 2016, Animal Research, the 3 R's and the Internet of Things, Opportunities and Oversight in International Pharmaceutical Development. Steve Nemi and Gail Davies were the authors of this wonderful article. And it really talked about standardizations of global data collections and analytics and increased sharing, but it also alluded a lot to the ability to improve welfare and care and better understanding through regional effects of environmental variables and remote vivarium monitoring as well, allowing us better reactivity and collaborations than in looking at how those different areas are. One of the big things we are seeing is a lot of issues with reproducibility. Reproducibility is a concern at several levels, but understanding where the concerns are is difficult at times, and these systems are very helpful in understanding how some of those concerns are developed and where they really are. So we can sustain and support research, utility, husbandry, veterinary care, ethics is framed by the 3 R's through use of a lot of this technology that's out there with that. With the Internet of Things, we also can talk about the Internet of Animals, which was introduced back in 2016 as well. And this was an interesting concept in that we're talking about wearables or genetically engineered animals, geotagged, monitored, and interconnected, where we can monitor some of the field studies of how ecology is changing, and then the massive movements of wild animals, and then also go back into owner and veterinary communications and look at those type of interreactions there. So it really gets down to how granular can we go? Can we go to the Internet of the Vivarium? Can we start looking at how we interplay within the vivarium and how changing one thing affects several others down the line, and how this affects things globally as well with those internets, with the Internet of the Vivarium and the ability for some of the global data analysis and work that way. So if we talk about the Internet of the Vivarium, one of the things that I wanted to propose was looking at the very basics and the very baby steps, and starting with cage change out management. How would that work? We could start looking at dirty cage units self-identified, then cage out units and inventory identified, and resources for those cage outs identified. Initiation with a personal resource management system to go ahead and allow personnel there for the cage change outs, and then schedule of the cage unit delivery, change out, and then delivery to cage-wise schedule and perform. So in speaking of baby steps, what I want to do is take us to a facility that is in Prague, Czechoslovakia, and talk about what they have done at this particular facility, which is the Institute of Molecular Genetics. This is a facility that has had a lot of background in regards to going ahead and developing their supply of mice to all of Europe. And they're a breeder facility. They have a lot of transgenics there. They also run a mutant colony there, and they're also a phenotype core. So they're very well known. They are a center of excellence with this, but they were running out of space. And in addition to running out of space, they were running into some issues of not having a barrier in their experimental facility, which then caused some contamination issues. So long story short, they built a new facility. That new facility, here's the indications for their Europe-centric supply for mice that way. And the new facility is actually in Vestek, which is about 9 miles south of Prague. This facility is called BioSeed. BioSeed is several different institutions that have gotten together that have supported this. It's a four-floor animal facility, new as of 2016. They're still building and developing in the facility. It is both a barrier breeding facility and a barrier experimental facility, and they have a very good quarantine there. Capacity of this facility is about 13,000 cages of mice and about 3,400 cages of rats. So looking at this facility, we've got several different areas of it. This is one of the mouse areas here outlined in red. This is this is a rat area outlined in red here. And then this area is actually a DVC, strictly using the DVC caging, the EMF caging in this area here. This little area is a test area for looking at the caging. It's outside of the barrier area. This whole area is the barrier breeding facility on the bottom floor of this facility. Their cage wash is actually 2 floors up, and they move the dirty cages from that area on up into the main cage wash area from there. So looking at this, I wanted to then dive into how the DVC cage itself works. And the DVC cage is based upon developing an electromagnetic field and then measuring that electromagnetic field. This is an extremely low, very tiny electromagnetic field that is much less than what we are exposed to on a daily basis overall. It's done by having a current go through an electrical plate, and then you develop a basic electromagnetic field from that. There are 12 primary sensory receivers here in the electric plate. These electric plates are underneath each holding cage in the rack. So the rack is of normal size and dimension and density. And the cages then sit on top of these electromagnetic plates, if you will, electric plates. And the ELF, which is impacted by dielectric materials like mice, will then give a different signal coming back from the animals that way when they're in the presence of one of those proprietary sensors. There's 24/7 continuous welfare checking and auto phenotyping in regards to this. So realistically, in showing you more diagrammatically here, what will happen with the signals when you have an empty cage with dirty bedding, presence of an animal moving away, and cage with wet bedding. Now, I think one thing that can be confusing is that these areas here, both the animal movement and the cage evaluation, the substrate evaluation, is done simultaneously through algorithms. So this system allows simultaneous algorithm interpretation of both animal movement and of the cage condition. Very important in terms of the management as well as the activity of the animals overall. So going back into the BioSieve facility and their specific area with the DVC system or the EMF system, what was done first was a learning phase. So 20 cages with 2 animals, then 20 cages with 3 animals, 20 cages with 4 animals, and 20 cages with 5 animals. This declared what a dirty cage was for the system based on density, based on these densities overall. So each individual facility is going to have their own SOP for how dirty a cage is, and this system will allow you to have that diversity in regards to what a dirty cage is. So you can go ahead and direct the system, and the system learns as well as it's in progress as to what dirty cages are overall. With this, after that had been done, the first phase was running for 89 days without using the DVC turned on. This was the calendar-based system and giving an idea of how many cages were actually changed in that period with the amount of cages in the area. The other next phase that was done was with the DVC on, and then this was going ahead and looking at criteria-based changes, again an 89-day period, and looking at comparisons then from period 1 to period 2. The density, stocking densities that we were looking at in here in regards to total, again, this was an area that could hold up to about 6,000 cages, but at the current time they were still building. So the caging that they have there is about 2,400. Then with 1 animal, 2 animal, 3 animal, 4 animal, and 5 animals, you can see the stocking densities here, and then the breeding cages that were involved with those too. There is a preponderance of 1 animal here. A lot of these were individual transgenic males and females with their pups overall. So that's why you're seeing a higher incidence with that. A lot of what you would need to look at in your own facility is what these densities are within your own facility. That's a very critical aspect of this overall. What I'm going to show you next is probably the most important slide overall for this particular set. And this is the slide that shows the differences then in terms of the cage change interval comparison. On the average, the total average with different stocking densities across the board, we were seeing 13.4 days on a 14-day change cycle. With the DVC system, you were getting then 23.29 days related to that, so almost a 10-day increase there. But again, if we get into the data and really look at 1 animal per cage, there was a 13-day increase there. With 2 animals per cage, realistically, we're looking at about a 12-day increase here. With 3 animals per cage, we're looking at about a 10-day increase here. So again, when we got down into the 4 and 5 animals, the differences were not that great, but there still was a increase here. And again, depending on your stock and strains of animals, these were predominantly C57 Black 6s or Valve Cs. If you're dealing with other stocks and strains that may be more higher producers of urine and issues that way, you may see a decrease in the 4 animal and 5 animal cage change period here based on the dirtiness that you want overall. It may be more effective in evaluating that and doing that for you. So that's, again, looking at animal welfare with that. The big thing here is there was a 40% reduction overall that we're talking about with that. So we're seeing a 40% reduction for the animals in relationship to that. I wanted to do the math for you. Actually, that was an approximate 40. It was actually a 42.47%. And again, if we go back and look at with 5 cages and do the actual math related to that, what we're looking at in terms of the cage change savings for the area, based again upon the 5,000 cages and based again upon these averages that we have of stocking densities and those stocking densities staying in the same areas, we would have 57,834 saved cage changes. So that's a pretty important number. And going forward with that, then in regards to that number, one of the things that I think we need to keep in mind here is that we could be seeing in terms of washing an animal holding area for the actual savings in time of 100 seconds. So a time motion study was done, and this was split between clean cage transport and dirty cage transport. And again, that's going to be quite variable in all your facilities. So it was better to do this not in terms of money, but actually in terms of looking at time. And what was looked at for this 100 seconds overall was that the cage system here okay, if we're looking at the amount of seconds that we're splitting out here, is that we're at 76.04 for the clean aspect and 23.99 for the dirty aspect. So this translates then into actually how many hours per annum and how many days per annum as well in relationship to those specific areas. Moving forward on that and looking at then what that would be overall, depending on if you're on an 8 hour per day workday or a 7 hour per day workday. This could either be 48 days or 55 days for the dirty technician time only. For the clean technician time, if you're looking at that, we're seeing that this could be at 158 days or 174.6 days if it's a 7-hour per day versus an 8-hour per day. There's a lot of variability with that again. So the one thing that we don't have a lot of variability with is how much substrate it would save. And that substrate is about 11,200 kilograms of substrate. So all in all, there's quite a significant savings that way. I wanted to point out that this was done in collaboration. There were other groups that were working on this as well. What I've shown you is the most recent data, but BioServe is a group we just looked at. We'll look at another group here shortly. These are all European groups here, whereas this here tends to be the U.S. Contingency right now. So there is an active group working overall with this. And perspectives from leadership in regards to the Netherlands and Leiden University. Just wanted to show you that there was an experimental design for a very similar beta study in regards to changing, not using as many cages, only 60 cages, and then doing this with 10 animals with the different stocking densities, and then getting the results in relationship much similar to what was done in the previous study, phase 1, phase 2, and phase 3, and getting ideas of the differences in regards to the DVC-directed cage change-out and cage change algorithm as the final phase 3. And the bottom line in this was that there was good validation correlation with what we had just seen from BioServe. So this is, and others that I've talked to have gone up as high as 65%, and others have gone as low as 30% on this. So again, there's variability here, and I think the bottom line with all this is there's a significant reduction of cage changes per unit of time while maintaining acceptable cage conditions through use of digitalization systems for the caging overall. The translation, with the particular Netherlands study that was done, was looking at a 12,000 cage change then if that was being done. And this gives you some data in relationship to that as an estimated savings overall. Not realistic. The other one from BioSeed was actually realistic because of the amount of cages that were being used in those areas and how many were being put through there. So again, it goes back to your stocking densities though and moving that way. The other thing that this allows is we go from this calendar system that we've been indoctrinated in for many years and been non-flexible with, to a system that now allows us to have quite a lot of variation and ability and latitude in how we use our resources. I should point out as well that the system is careful not to go ahead and save up a 3,000 cage change for one day. They will anticipate if there are a bunch of dirty cages coming forward. So again, this is the learning phase that we're talking about and machine learning within the system itself. And when that system starts seeing that, it pushes some cage changes forward. It also recognizes weekends and holidays and allows then to work around those, if you will. And what I mean by that is moving cage change forward or going ahead and anticipating how dirty those cages might get and still being acceptable, though, but keeping them at a level where they can go ahead and move around that. So the system is very sophisticated in regards to this, but it is user-friendly and has a great interface as well in the ability to do that. So going forward, and again, kind of concluding with this, talking about this cage change wash initiation schedule and going through all of the aspects of that for a Internet of the Vivarium and a smart building, we would need to then go ahead and tie that into the cage wash and evaluate how many dirty units are coming down, have resources available for that, and then allocate those resources and be able to move them through that way. And with some of our software systems, in terms of management, we're actually able to start to do some of this already. So it's a very exciting time for us, I think, in regards to all of this. So what I did want to mention is that we talked only about the bedding conditions so far and a little bit about animal activity, But there are several other things that can be done with these systems, with these digital systems as well. And I think that's important. We also talked a little bit about the food and water levels, but there are many things that can be done with these, and I think that they can be add-ons and expansion as well. So it's an exciting time for us in the lab animal community. I wanted to get into a little bit more on the activity and just show you a little bit of how that works. So again, we said these algorithms can be run at the same time that we're seeing with the cage change or with the cage conditions. And if we look at the drop of that signal and how many signals we're getting from just one of the sensors, that's 240 samples in 1 minute. We're looking at about 3,000 samples per minute in relationship to the board. And that translates out to many signals per hour. But I want to compare this to the video systems and have you recognize that with the video systems, the amount of data that's actually being pushed forward there is much higher than what we are seeing here with some of the with the EMF system overall. So there is a lot of data. You need to understand how you're going to manage that data. And it's really important as to who has access to the data. Do the investigators need access to the data? Obviously, managers in the facility will need access to the data. And how often do they need that data? And then how long are you going to store the data? I think as we move forward with these mega data sets and other large data compulations that we're seeing, storage of data is becoming more costly, actually, than some of the using some of the systems to analyze the data itself and to move forward with it. So this is something that should be looked at from the administrative level regarding this overall. Getting back into the heat map and talking about activity levels, we can see here that on a heat map, and that just shows where the red is it's more active. We're having a cage change or monitoring a cage here over a 10-day period. And during that, in that 10-day period on day 3, there was a cage change, none. And what is readily apparent from this heat map is that you can see related to that cage change that there's a lot more activity up here than there would be on other days that would not have as much activity there. So anytime you change a cage, the bottom line of this is that you're creating a lot more stress on those animals, and there's a lot more activity for either pheromone marking or marking the cage on those animals, a lot more increased activity and disruptions where normally in the nighttime there's high activity, and that's where you see most of the activity. And actually it's kind of a biphasic early on, and then later in the night you see that occurring right before the morning time period and kind of a feeding area here as well. And it's interesting to be able to see that and notice that in different strains that we do have. So the one thing that we wanted to look at is what happens if you do diet restriction. What are the activity changes that might be occurring with diet restriction? This was done through the consortium that I showed you earlier, and this was done up in Sweden at the Karolinska Institute. And what we're actually seeing is where when I showed you the first heat map, you saw that during the night there was great high activity, during the day very low. What we're seeing is a reversal of that in the diet restriction animals. Now these animals were fed at 10 o'clock overall. So that really caused some issues in regards to, they were fed at noon. So these animals were fed at noon. So what you're seeing is where these animals are hungry and they want to get fed. So instead of waiting into the night period to eat, they immediately went to the feeder. And is this affecting then their circadian rhythm and some of the issues that might be behaviorally important for the investigator and some of the areas that they're looking at? So really we need to be cognizant of this and be very careful of how we're feeding animals on diet restriction and when we feed them related to their normal activity period and how that occurs. One of the other things that I wanted to show here was a breeding algorithm and show how this can be used to help predict when parturition might occur in caging. And what we see are a couple different things here with this is where the animals are starting to congregate in one corner of the cage predominantly. And this is in a paired system. We are working on harem as well and getting better definition with the harem systems and how those are working. But what we are seeing is within these systems is where They're going into the corners of the cage and staying in that corner, and that's high predictability of when that happens. But even a better predictability of this and more effective is the average velocity of the animal, how fast it's moving. And as it decreases its velocity, there's a higher predictability for the parturition as well. So both of those together, going in the corner and decreased velocity, gives a very high confidence rate for when parturition will occur in these animals. Another thing that can be used for the activity monitoring is phenotyping. A lot of places are looking at many different transgenics, and what we are seeing is a huge increase with CRISPR-Cas9 and transgenic creation. So as a result of that, going through and doing the phenotyping on these is very important. This particular one is with the ALS syndrome, and looking at SOD1 mice, which are a model for ALS, and being able to predict when these animals are developing this disease process, because the pathology often precludes or is earlier, much earlier on than the clinical signs. And it's important for the research to be able to find the pathology first and then to address that pathology. So by looking at animal movement, we can actually understand when the pathology is starting, and do this at a much earlier time period, as being shown here with the one animal, SOD animal, two SOD animals, and then again in a different graphical depiction here showing affected animals being able to be seen much earlier than when the control animals are there as well. So it's a definite advantage for the investigators who are active in this area and who need to have earlier clinical symptomology or actually pathology identified, and not just rely on the clinical symptomology, because often by the time they're showing the clinical signs, it's too late for some of the things that they want to intervene with. My last part of this presentation will just be talking about stroke and evaluating some of the stroke models here. We're using this system to help evaluate a stroke model overall, and being able to see how that can be used for intervention in the stroke model and evaluation. So this was doing a timed 30-minute unilateral occlusion of the middle cerebral artery. And the design of the experiment was doing some behavioral testing ahead of time, baseline, then doing the actual stroke, and then going ahead and giving different diets in relationship to stroke therapies overall and how effective these diets might be. These are antioxidant diets. They're based on fish oils, omega-3s actually, heavy in that. So this is some of the things that were being looked at with this. Some of the behavior tests that were done were open field, rotor-rod, grip strength, pull test, and novel object recognitions. So these are the control diet was your basic diet that way, and then the forced-in diet was the antioxidant omega-3 rich fish oil diet that way. In open field activity, when that was done by the postdocs here, velocity and distance walked after stroke, there was no dietary effect noticed with this. And then 14-day post-stroke, really again, no dietary effect was noticed with this. The pull testing on this, mouse on the forcing turned a little bit faster, and they had improved motor coordination. And actually with the cerebral blood flow, what we're seeing here is that there was a increase of cerebral blood flow with the forcing at day 35 in that right hemisphere, right hippocampus at day 35 with the animals that way. So the question came up, well, what about the open field results, and could there be a better way to look at this maybe with the DVC? And so there was a little bit of things that they wanted to look at in terms of the distance, the velocity, and then the angulations using the DVC system, and then comparing that somewhat to the open field overall. One of the big things that this did allow as well is to look at where the major activity was. When the lights were off, as we would have assumed, there was a lot more activity overall in the animals across the board, both in controls and in the dietary animals that way. Activation on the boards in regards to centers, corners, walls, and global cage much more activity in the evening hours again, and again into the corners, we seem to see more because, again, these guys are more thigmotactic that way. So the comparison, if we look at lights on, lights off in the diet and control groups, we could see that there was much higher activity in the dietary groups in the evenings overall. Activation on the boards, again, showing some of the activations with the different control diets and then test diets at beginning and at the end of the studies showed that there was more activations there. Distance walk, displacement length, looking at it then with the open field during the day and the DVC at night. The distance walked increased over time during the night for this, and it's almost a reversal of what was being seen here with the open fields. This is pretty critical for their study and for some of the things that we're looking at. And then activities in the corners, we saw more activity on the Forsen diet in the corners, especially at the nighttime. So again, looking in the evening rather than the daytime and evaluating these animals in their proper time period of when their behavior is the most active, or their normal behavior, we might say, is occurring rather than in daytime when it's abnormal, or their nighttime behavior where they're resting usually. So really critical for the study. And it increased at night again due to the diet that way. One of the questions that came up by the investigator was, is there more stress with some of these different testing modalities that they're doing, the different behavior testings? So one of the things they looked at was how much activity there is post-testing, and then correlating that to possibility of it being a stressful event if there's higher activity, because of the fact of what we had seen actually with the cage changes and others, where animals are aroused and they're more active and they're a little more stressed in relationship to what they're doing that way, and may take them a little longer to settle down post the studies that way. So in doing this, the stress activity levels 4 hours before and 4 hours after every test. No particular stress returned to the home cage after testing with the open field or the pole testing, but the grip test was somewhat stressful, it appeared, because it was quite an increase. There was a slight increase in the neuroimaging and rotor rod, but again, the grip test was most apparent as being the most, creating the most. And then the advantage of the DVC over open field is that we are looking at where monitoring the subtle changes in activity, walking patterns, and location of the animals can't be detected in current experimental settings with the open field. Last week, all mice were more active, faster, longer distance than the first week. Monitoring activity before and after test showed a significant increase in movement during the first 4 hours after the grip test compared to 4 hours before the test. So is it stressful? Again, that's an assumption there. It's not a proven entity. But it would seem that way. Animals on control diets sit more in corners, they're less active, and have preference for left turns in the first week compared to the Forsen diet. So, again, this is valuable data for the investigator for looking at that type of dietary replacement and correction for stroke, and also for people who have stroke. So what we can say in our summary slide here is that cage automation is evolving. It is the internet of the vivarium, I would like to say. I think we're starting toward that. We're nowhere near it at any point now, but we're doing baby steps. And one of the first baby steps is this cage technology, and looking toward that and moving in that direction. Vivarium architecture and design components need to be able to incorporate and support these systems in regards to the new facility designs and retrofitting, and being able to support some of the high databases that we need. And then how are you going to store that data, and where are you going to store that data? The advantage of this is dual room usage, both holding and study, allows rapid study scalability and flexibility in regards to using some of the digitalized caging for study results. At this point in time, I'd like to thank you for this long presentation. I didn't mean it to be this long. It just got that way. And then I'll take any questions that we might have at this time.
Thank you, John Hasenau, for that informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question drop-down box located on the far left of your presentation window. Type your questions into the box that appears on your screen and click on the Send button. We'll answer as many of your questions as we have time for. Let's get started. Our first question is, what safety testing has been done with these continuous home cage systems?
With a lot of the video systems and the metabolic systems, the infrared beam brake systems, vibration systems, I'm not aware of much safety testing that's been done or evaluation of those. With the EMF, I'm more familiar with that, and I can say that the company that has been working with this has done a year-long study with the EMF at a level that would be used during study, looking both clinical pathology and pathology. This was presented in the PHELOSA meeting symposium that was held in Brussels, and the results of that showed that there were no significant pathological changes, either clinical pathology or histological pathology, related to its system's use. It's also had the EMF itself has had a lot of discussion in regards to phone technology, although that is a much higher hertz level than what we're seeing with this technology. And again, there's been extensive testing and other things that have been done with that. And as we all know, we all are relatively easily using our phones still and have that technology in hand most of the time of the day. So I can fairly safely say here that I think it's a very safe system, and we have not seen issues with this at all. Hopefully that answered the question.
Thank you. Our next question is, what is the ROI that you would see with the DVC component for just doing the cage changes?
Good question, but so there's a lot of variables here, and one of the things that we really need to think about is each institution and the stocking densities at each institution. As I showed you in the presentation, if you have a lot of ones, twos, or threes, your ROI is going to be really good because it's going to be pretty quick in terms of how high your change out intervals are going to be increased. Related to that, fours and fives, stocking density, you may not have as great return of investment on those over time. But I think, I think the question was just for the cage change outs. So that's, one part of it. The other thing that I showed in the presentation that I didn't elaborate on was that was just a technician time that I was showing a good savings on there in terms of the days. What I did not show was utility savings, wear and tear on the caging, the amount of caging backup that you need in terms of stock for cage change outs, and then also wear and tear on caging equipment, the cage washers themselves, related to how much caging you're putting through. So that's just one area that you're saving with this. So I think there probably are further talks that could be done on that and really evaluate that as well in relationship to that. So it's hard to say. There is no one set number that you can come up with, but it would be more of a formula, looking at first the stocking densities and kind of getting that in hand, and then going ahead and putting in the other variables there. Are you working on a 7-hour workday or 8-hour workday? What's the actual realistic workday that you have there? Those are all factors as well.
Thank you. Our next question is, how do you engage the care staff towards these systems and encourage their acceptance?
Yeah, I remember when the first time the staffs were starting to see the robotic washers coming through, and that, walking through ALAS, the ALAS shows with staff and getting their feedback from that, and quite a lot of worry on their part in terms of being replaced. I think, one of the things that we have to encourage everyone about is that, are we doing everything that we should be doing currently in the facilities in relationship to the time allocations that we have? And then how thoroughly can we really look at a cage in relationship to, all the cages in the facility and really evaluate those over time? I think that's an important concept for the staff to have as well, and that we're augmenting them, not replacing them. This is an augmentation. This should help them in what they're doing, and that this would be benefiting welfare as well for the animals in relationship to when we can find these cages that are either dirty or flooded or other problems that way, and react to them in a timely fashion. A lot of these, the systems in Europe as they're running now, and some of these in the U.S., are running in the evenings when no one's in the facility and the animals are at their high activity time periods. And then what's happening is, they're doing their algorithms early in the morning, and what is happening then is, and that's before the staff comes in, and then they're creating, the reports right before the staff comes in. So the staff has the ability to address these issues that are found through the systems right off, first thing in the morning, early on. And again, that can be adjusted too, so that there could be a PM shift coming in if there were, a rack that had extremely valuable animals. But I think that the major thing for the engagement of the staff and encouragement of acceptance here, as I understand the question, is that the staff is not being replaced. It's augmenting the welfare and the care of the animals overall, and should be, accepted more, as we talked about in the talk. The other good thing to do might be to take the staff down and walk them through cage wash and show, okay, here's, 100 cages. Out of these 100 cages, how many of these cages really, really needed to be changed at the calendar time when we're looking at this? And I've done that in some facilities, and it's amazing, the responses you get is, oh my gosh, what waste we're doing here. So those are approaches that that could possibly be used, and things that could be done that way.